Hello, everyone. I'm just going to try to find the non-squeaky spots here. Not sure where they are. Just let me know if I'm squeaking. So I'm Jan Mortensen, and we're going to do this presentation. But first of all, I just want to give credit to these two guys who are the original authors of this one. So it's my colleague Mohammed and Jon Olav from Microsoft. So they have both created this presentation, and so we reshuffled it a little bit and made it ours. But that's another thing. But as mentioned, I am Jan Mortensen. I call myself an advisor. If I were allowed by Equinor, I would call myself an OSDU evangelist. But apparently we don't have evangelists in Equinor, so that's a shame. And with me today I have...
I'm Nishita Sanala. Thanks for joining this call or this meeting. I'm from Microsoft. I work on the Azure Data Manager for Energy team, focused on AI and analytics. So with that, back to you.
Thank you. Right. So, blank slide. Interesting. How can we trust OSDU? Now, both the data and the platform at scale. And the thinking is our 2025 goals for the OSDU data platform in Equinor was, we said we need trust in the platform and trust in the data. Now, trust in the platform for us was basically seeing that we adhered to any Equinor-specific governing documents. So it's like technical requirements, work requirements, all that stuff to make sure that we ticked off all the right boxes so that all the leading advisors in Equinor would just nod and say, yeah, that sounds good. Now, with regards to trust in the data, now that's a bit what we're going to talk about today. We do have a pattern in Equinor where we foresee we're going to have many, many data producer teams that are empowered by the data owners to make their data available in OSDU. So we're going to have a lot of different ways of getting data into OSDU, and we want to keep a low threshold to make sure that we capture the data and then rather do the evaluation from the platform. So that's why we need the at-scale thing, and we also need to be able to capture this. So the challenge is, as mentioned, and a lot of this will seem familiar because you saw the BP presentation as well. So a lot of this will be around the same issues and how we can solve them. Now, we have things like schema violations, where somebody is writing data and that for some reason is not captured by OSDU. So you basically write invalid JSON structures to OSDU. Fully possible to do. We also have broken references. That is another thing where you put data into OSDU, and as mentioned, we're going to have many data producer teams, so you don't have actually control over what you reference. So if they, for some reason, break good practice, you might actually be, you were good when you started, but maybe it's bad tomorrow because somebody did something. And of course, we want to implement data quality checks that is possible to do, but it's hard to scale. So the framework we created is we need to capture all this data, and we run our schema validation from the platform after the fact. We expect every data producer team to actually be professional enough to do this check before, but if they don't, we find it in the platform. Same thing with referential integrity. Once again, we expect people to check for referential integrity before they write it to OSDU, but if they don't, we will capture it. And once again, because of delegated responsibility of data types, we will also capture if somebody else breaks your work. And then we can notify the right parties. And finally, we have the AI-driven data quality rules, and I'll mention a little bit about what I mean with AI-driven. Now, I have the utilizing the standard. So we really, really want to use the capabilities of OSDU to do this. So as mentioned, schema validation, well, it's, are you following the standards, even custom schemas, right? They also can be validated. Referential integrity is also something you check according to the standard. And when we talk about data quality rules, we really want to utilize the reference data quality rule, data quality rule sets, and when we get the result, we want to use the work product component data quality to capture that back into OSDU. So that's all integrated in our system. What I'm going to do for the rest of the presentation is going to be mainly about AI-driven data quality rules. And let's see what we mean about that. So the challenge, of course, millions of nested JSON records, and you can't have people checking them manually. And also, the ones who actually know what's the right thing, the business users, they might not necessarily know how to create a data quality rule to actually check for this. So one of the things we would really like to do is to try to make a way to capture the business knowledge of all the stuff they want to check, and for this to be created as a data quality rule within our OSDU instance without putting a not scalable team between the business user and the actual creation of the rule. And then, of course, we have AI. AI solves everything, right? So what if our business users, our SMEs, those who actually knows what they want to check, what if they could just write it in natural language? And our framework tries to figure out what they want to do and then create a rule out of it. Like spatial location should exist. Typically part of a longer thing. If it exists, then you want to do some other stuff. But then we have the user input. We have the AI trying to interpret what the user actually said. It actually tries to go through all the schemas that is available to try to match the wording with what the user said. It creates a rule and capture it. And then you can also do some validation to see, does it seem to be what you were looking for? If it is, you can now use this rule going forward. So we created this data quality engine in Microsoft Fabric. And of course, the Fabric part is the scaling thing. So we'll get back to some of that part. But this is the, if you use, you can go a long way with OSDU if you use standard search. So we have millions of records in our OSDU. And if you're able to do an aggregate by, then you can get answers in milliseconds. And then you can capture that result and even go deeper, but it's always one dimension. If you want to go multi-dimension, if you want to check across, then you start doing cursor searches. And at some point, that just doesn't scale anymore. So, as mentioned, the high-level workflow, the rule creation, we execute that rule, and we do capture the results and write the result back to OSDU. So currently, this is only in a notebook. So we only have captured this in a notebook, and the business users we have talked with so far, they feel comfortable with this. So that's fine. And this is typically what it would look like. So it's not very clear, but up there in the corner you have, they just write spatial location should exist. And then it creates a rule. Now, for those who have actually used the data quality, looked at the data quality rule, they'll see something's happening there in the bigger picture. So we kind of cheat a little bit here, and it was also mentioned during the BP, I think, and also I think Jacob Jackson actually asked the one, how to create deterministic rules in the current data quality rule, because it's a string, right? A rule assessment is a string, so you can write anything there. I want my record to be nice. That is a valid quality rule. Doesn't make any sense, but it's valid. So we extended it a little bit and created our version of this. And I'll get back to this thing. So this is an Equinor thing. Now, when we have this, we create a rule set here, and we can choose which rules we want to do. And then we can run the evaluation. Here, we actually run it on an entire geospatial rule set. And then by run the evaluation, it will actually run for all the relevant records in our system, disregarding how many they are, because all the data available is now in Fabric. So this is where you don't need to confine yourself to like aggregate by in this single dimension. You can run it on whatever scale you want. You create an evaluation summary, and then finally you write the rules, the rule sets, and the results back to OSDU. Now, the impact is to make it business accessible, to remove the choke point, right? The fact that you need an engineering team between, because we are foreseeing, because of the way we want all these multiple teams, we really want to apply Equinor's data governance fully within the data quality rules. So we foresee thousands of rules that checks all kinds of small tidbits of knowledge that you want to capture. And not only from the data owners, but also for specialist groups like domain groups like geospatial, which is one of those we are collaborating with. And this makes it a way for them to actually contribute at scale. The fact that we can run these rules across millions of records, that's another part of the scalable thing. Everything is stored and traceable in OSDU using the standard. And of course, when you have it down there on this level, you can also start doing wide analytics, and with a bit of magical sprinkle on top of it, you can even do some AI. And then I'll hand it over to Microsoft to do the architecture thing.
Thank you, Jan. So how did we all do this, right? How did we get here? Data is in OSDU instance, which we call the Azure Data Manager for Energy, which is a Microsoft offering. So Equinor is using ADME with millions of records in it. And we wanted to liberate this data from ADME into a Lakehouse. This is where the Lakehouse architecture comes. We followed the standard medallion architecture. We use PySpark notebooks, which we call the ADME Fabric connector, to get the data from ADME into the Lakehouse Bronze Lake. So basically, it's raw data as it is in ADME today. Then on top of it, Equinor has built the silver and gold layers to extract and do more work on it. Now, like Jan was saying, while one of the use cases for this Lakehouse architecture today is this quality checks, but because the data is now available in Lakehouse, you can do other analytical and AI use cases as well. You could build AI models. You can use the entire data and AI platform tools and services to build solutions of your choice. So that's what this enables. Sorry, some echo there. Maybe it got excited with Gen AI. So that's what this opens up. So what you have seen here is, instead of, we've seen a lot of examples today on why data quality is important. So we all know OSDU platform is a great standard for interoperability. On top of it, getting a good data quality enables a lot of things on top. Now, one of the ways that has been explored in this particular use case is more about, instead of being limited to some templates to check the quality, how can you use natural language by experts who can type it out and convert it into rules that can be implemented on top of the data that is available in Fabric in this case. Now, the way we pull data from Azure Data Manager for Energy that you see on the left top is again using OSDU APIs today. Now, the setting says, okay, I want these type of kinds of data into my Lakehouse, and then these Spark jobs run, and using OSDU APIs, today they pull it in. So that's the underlying architecture of how this has been enabled. And I will give it back to you, Jan, for further.
Thank you. Now, what next? So first of all, we have influenced the standards. This is where I got to, we put some Equinor stuff in there. Now, If you need custom stuff in OSDU, then please do so. But remember, you are not now building up the standard. So in this case, as was mentioned, there is now in the core concept group, there is a specialist part of that one looking at especially the data quality rule. How can we expand that to capture this type of information? Now, the goal of actually being able to do this is that you could have deterministic machine-readable rules, which means the same no matter who reads it, and not a string. So that work is in progress, and we will use that standard. So our Equinor thingy, we're going to drop that like a hot potato when we get an alternative. In-house or off the shelf? Now, currently, we have created our own data quality engine. And so it's an in-house thing. Now, we're not a software company, right? So we would prefer to have something off the shelf. But once again, we created our own thing, so right now the only way we can do. So when we have the standard in place, suddenly you get the range of choice. Suddenly you can use any one of those vendors that's out there, but this is where it becomes crucial that no matter what data quality rule engine you choose, what package you choose, when you point those at the same rule, they give you the same level of trust on the data. If you have 3 different commercial data quality rule engines that looks at the same rule, and if the rule isn't defined in such a way that all of them will give the same result, we're going to have trouble. Having all of these things, so BP mentioned this, Chevron mentioned this as well. What do you do with things? How do you fix things when you find them? Capturing information is good, but you need to be able to create actionable outcomes. How to fix it, create those processes, make something happen with that. So, but step 1 is just having the information. We haven't started on this one, which is why it's on the what next part. And of course, end user solution. We have a notebook. And that's, so right now, the current users, fairly technical. We probably have some users that will back away when we show them a Jupyter notebook where they put their text and start. Even though we have buttons, it gets really confusing. So if we want to use this one, we probably need something better for this one with the AI thing. Or we give that away so it can be in one of the off-the-shelf solutions, or maybe in all of them. So, our data quality engine, trusted OSDU data at scale. Thank you.